Hey everyone, how's it going? Welcome to the stream. So let me do a quick recap. So a couple nights ago, kept working on writing tests, and we finished writing tests for primitive types. We actually found a bug, which is pretty cool. So this is the test we have here now, looking good. So I want to continue working on that. Now, one thing that came up last stream that I wanted to just see if I could take a stab at this was this thing right here, traverse. So I have this little helper function that I wrote that allows, kind of generic traversal of nodes that have members called children, basically what you see here. I wanted to write a version of this that if the callback returns a bool, then the callback could return true if it wants to keep going or false if it wants to stop. So I was thinking of doing that. Now, to do this, I'm going to need some kind of trait that lets me know if the result type is a bool. Unfortunately, I don't think C++ has such a thing. Let me just take a quick look again. C++ type trait result type of function, or callable. So maybe this here. So it looks like this was actually removed. But since C++ 17 we have invoke result. Deduces the return type of an invoke expression at compile time. F must be a callable type, reference a function, or so this might actually be what we want. Result of t here. It could be interesting if this works. So let's see if this works. I'll do it here. I don't know. What do I do here? Let's see. So result of stood, result of t. Just want to see if this even. I guess this needs to be a callable. So let's say I did like this. Okay. Does this actually do something? Error type. Let's build this and see what we get. Because if this works, then I could do an if const expr, I think, in my template function there. These are deprecated. Supersede. Oh, did I use the wrong one? Okay, because I wanted invoke result. All right, cool. Let's see. I wonder why they changed it. Is this because they want you to use stood invoke? Maybe that's why. There you go. And it even says int. All right. So let's say. I'm just going to grab this. I'm going to copy it into here because it's going to be faster for me to iterate from here. I'm going to call this traverse 2, let's say. So the idea I was having was something like this. If I do if const expr, and then we do this thing. If the result of this guy is equal to, and we say, what do I say here? I mean, I can't really do this, right? Can I? If not this, return. Okay, let's see if this even builds. That seems to build, so that's interesting. Now let's see if it actually does what we think. So here we would use traverse 2. And what we would want to do is return false. Let's see. Well, not really quite like this. So the idea would be we do the find if. If we found it, return false, which means we're done. Otherwise, return true, which means we want to keep going. All right, so now it's actually invoking the thing here. Type is not a member of any direct or indirect base class of std invoke traits void callback. Callback anonymous namespace find variable by name lambda. Yeah. Type is not a member of any direct or indirect base class of std invoke traits void comma callback. Now the callback is indeed this lambda here. Like if I say that it returns bool, does that change anything? So it's trying to reach in there and get the type def here called type from invoke traits for the callable, which is my callback, which is the lambda expression. And for some reason, I mean, it's true that I didn't try with a lambda expression. It should work though. So what does it say here? Invoke result. F must be a callable type, reference to function, or reference to a callable type. Invoking F with archetypes must be a well-formed expression. Lambda, let's see. Hard error when using std invoke result T with a generic lambda. Well, mine's not a generic lambda. Lambdas have deduced return type, unless you specify the return type explicitly. Thus, std invoke result T has to instantiate the body in order to determine the return type. This instantiation is not in the immediate context and causes a hard error. You can make your code compile by writing blah. Okay. Oh, is it because I gotta pass archetypes? Wait a minute. Oh, I see. No, this looks like it should work. So here are types of functions. Maybe I gotta decal type it. For this, they use pointer to member function. Why is everything so complicated? Shouldn't be this complicated. See, here they do actually pass tref here. I don't think it's going to change anything. Yeah, exactly. This should totally have worked. Okay, let me try a simplified example. So if we just bring this back, going back to what I had here, like, okay, let's say we whoops. All right, so I have basically the same type here, a function as a lambda. I put into f here, so there's our lambda. You can see even Visual Studio shows us that the lambda is a bool that takes a shared pointer. Okay, so that now we want to try std invoke result t of f. So let's see, already here it's complaining. F is not a valid template argument for parameter callable. Why not? F is not a valid template type argument for parameter callable. What? Std result of gives wrong result for lambda function. Why do I need to sign in to see this? I don't want to sign in. Okay, so now I wonder, if I was to pass in the argument type, would it change something? So this takes a const, like this shared pointer here. Is this what it wants to see? I'm not sure what's going on. I didn't think it would be complicated, but let me try, instead of invoca, let's try result of lambda expression. Why does std result of not work with lambdas? Okay, that looks interesting. Your code not valid C++ because function parameter types cannot be auto. This syntax has been, what do you mean? Oh, I see. Okay, but here they are doing the decal type thing. So they're constructing an instance of the callable. Is that what I need to do? Decal type of f, like that. No, I mean, I have the type here, so this doesn't make any sense. Okay, fine. What if I was to use callback, since I have that? Oh, look at that. I think this might actually work. Okay, that compiles. So that's using the invoke result t. So this looks like we're getting a bit closer. So now coming back here, what we might want to do is up here, and we say decal type. I guess I could just say decal type of callback in that case. Oh no, okay, it's instantiation of this guy. All right. And then if we bring this back to, well, this should build still. And we bring this to traverse 2. Let's see. Still doesn't like it. Decal type expects an expression, not a type. How is that any different from what I had here? F is not an expression. Oh yeah, it's a variable, that's true. Okay, so I think we're getting closer. Now it doesn't like this equals bool, which I think makes sense because we need, what is it? Oh, I know what we need to do. We need to say std is same v, this type, and bool, like that. Use another type trait. Oh, look at that. Okay, so that's interesting. So let's see if this works. So we now have this traverse 2 here. Okay, I can get rid of this stuff here. I'm gonna just put it in comments for now. And well, we have a find variable by name, like over here. Let's see if this actually works. All right, so we go in here. Now here we are. So it went into the other callback. So it didn't actually pick this one, which means that it did not see the return type as being Boolean for some reason. So that's not what I was expecting. Well, that's a shame. Oh, wait. So maybe it did work, and it's just a debugger that's not showing it to me properly. Because it didn't continue iterating in that case. That's interesting. Try again. I'm also realizing that I should probably take that shared pointer by const ref because I keep constructing them, which is not really what we want. See, like here, I would have wanted it to go on this line. No executable code of the debugger's target type is associated. Return false. Oh, is it because it has no children? Oh, that's why. Okay, so this is not quite working. Okay, so let me at least do this. Const ref this guy, and that. Should do the same thing with the callback, I suppose. Okay, so look, traverse 2 here, its lambda returns bool, right? So it's going to call this one, which just forwards to this one here, giving it the node and the callback. And then we say, if node is valid, now if const expr, so this is compile time, C++ 17, if const expr. If the result of the decal type of this guy instantiated, which to me really should have just been callback. I still don't understand what the difference is between those two, but anyway. So if we, well, I guess, yeah, I guess it's because we need to be able to give it the callable as a type. Let me see. Deduces the return type of an invoke expression in compile time. F must be a callable type, reference function, or reference to callable type. Invoking F with archetypes must be a well-formed expression. Yeah, I'm not sure what to do about the fact that I don't know. Well, I guess I do know what it could be called with. That's what I'm wondering. Am I supposed to do like this? Oh, that's interesting. So the decal type of callback of node, which is the call I'm about to make, and then the type that returns, instantiate that. Let's see if that does it. In fact, I guess I'll know if I just put a breakpoint there. Let's see. Oh, there we go. And then this one should not have been instantiated. Interesting. So this should do the trick. There we go. So it's going to call into this one. This should be const ref as well here. And we're going to do the find if. We did not find it, so we're going to return. Oh yeah, no, I mean we found it, so we're going to return false to say we are done. So at this point we're just going to return and we're done everything. The next one, it should find it on the second run for D here. So let's see what happens there. No, let me change this right away. Let's go to the second one. So here we are, D, come inside here. So we're not going to find it this time. Oh, we are. LD. Oh, right, it's because I only have one scope with a vector, so of course we're always going to find it. Yeah, this basically, I need to, in order to test this properly, I'm going to need to have like multiple scopes. Or, yeah, yes, exactly. I'm going to need multiple nested scopes. Here, let's just add one in here. We're going to search the root scope, and we're not going to find the second variable. So we're just going to call this, I don't know, int blah. Whatever. And we're going to try and do a there. Can't seem to get this camera right. Okay, so here we are trying to find blah. So this now should fail on the first run because there are multiple scopes to this function. So we're going to start with to traverse here. We're going to go in. We're going to go inside here. All right. So this find, there we go. So return true means keep going. And then we're going to traverse now on the second. So this is, oh, and I'm actually calling the wrong traverse there. That's great. There's also the question of whether I should make it that return true means I found it and return false means I haven't. That would probably make more sense. Go the other way around, right? It's kind of weird to say, yeah, let's go the other way around. Like the result of the callable shouldn't be, well, should it be true to keep, like true meaning we've succeeded so you don't have to keep going, and false meaning haven't succeeded, keep traversing. Yeah, I guess that makes more sense. I don't know. I don't know. It can go either way, I guess. I'll just document it. Okay, so this is the second time we recurse. Now we should find it. There's the result. We're going to return true. So that works. And there it is. Now I'm wondering if we should go further. So maybe it doesn't need to be a Boolean function, but rather a function that returns something convertible to Boolean. Because like in the case of, say, a shared pointer here, that's, you know, that is convertible to bool in a condition, and that would allow us to write a traverse function with a callable that returns, it could return a bool, but it could also return a pointer or a shared pointer to say that it succeeded. That would be even more flexible. And then I wouldn't have to do this little dance of like have a result in the local scope, capture that result here, you know, there's a capture. I set the result and return true. Rather, I just return it, you know, return result. The function would return this shared pointer variable. That would be ideal. So let's see if we can do that, taking this to the next level. So instead of saying is same v, I think it would be is convertible v. So if we do this, and we change our code here, like that. And here we just say return star iter. And then here we say return like this. And then this would be a return of the traverse. Oh, but, yeah, that's a good point. Traverse doesn't return anything. Huh. Yeah, so this means we would need to do this little trick of the invoke. It's a little bit gross, to be honest, but the return type would be this, wouldn't it? Actually, this would become an auto, and then like this. And similarly, auto here. Whoops. So now these are auto return types where the return type is defined. Now I have to do this because I want to define the return type in terms of one of the parameters of the function. But this would work, maybe. Let's see. Yeah, this must return a value. Now, if it's void, I think we're allowed to return void functions, right? Otherwise what? I need to return like the default constructible version, or I could just do this. That's what's nice about this stuff. I have unreachable code. Why is this unreachable? Oh, it's because of this return here. If, right. But this won't work for void. Oh, but we know this is not void here, right? Still unreachable. Let me think here. If I have a node, it's still valid. Do that. Whoops. I think I need to do the same thing here, but that's the problem, is that at this point I don't know. So I might have to do the if context where it has two different code paths. Like this, and then this one with the same if we see here. Auto result is equal to that, and return result. Okay, build succeeded. Wow, that's miraculous. Now let's see if this actually does the thing. If this works though, it'd be pretty cool. I would have made the traverse quite flexible. It's not like something I'd have to look at again. Just have to use it. So let's see. Do we have our breakpoint where we expect? So let's see. No, we don't. So this did not work. So I guess this is convertible thing is not what I think. I thought the return type, being a shared pointer, that would return that it's convertible to bool. See, it says it's false. Okay, didn't expect that. Oh, it's because it's explicit. I guess is convertible is an implicit conversion. Is that why? I didn't realize it was explicit. Yet we can put them in Boolean expressions without casting. Explicit operator bool checks if status stores a null pointer. Yeah, you see how you can just do if pointer? So what's explicit about that? Maybe that's for assignment to bool. Using implicit conversions. It says it right here. Like what I want to know is not if it's implicitly convertible to bool. I want to know if it can be used in a conditional expression, if that's well formed. Is there such a thing? No, okay, this is not it. I was all excited for a second. I wonder if I have to use enable if for this. Test and then type name. So the test would be something like I take the shared pointer, and do this. I don't know how to do this. Yeah, it's sort of what I want to do, actually. I think that's what I need to use, right? Because making it possible to use member functions, I want to see if I can invoke bool. But then again, I want the type. I can't get the type of that. I'm not sure. Basically, what I'm trying to do is determine if the type that is being returned, is this type convertible to a Boolean expression? Can it be put in as an if without any, like implicitly? It's too bad there's no explicitly convertible. How to determine if the type is whether or not one type explicitly convertible into another type? Oh, that's interesting. Wait, really? Is explicitly convertible, it actually exists? Well, that would help. When I looked up is convertible, I was hoping it would show me alternatives like that. I just don't believe this actually exists. I don't think this exists. No member. Oh, okay, so it's really specific to GCC? No kidding. In libstd C++? Huh. Wow, what do you know? Oh, it was removed, I see. I wonder why. Oh, I see. It's nothing but the inverse of is constructible. So if you can construct a bool explicitly from the thing. Yeah, I guess that makes sense. Let's try that. But I guess it's constructible. I think we want it the other way around, right? Is a bool constructible from a shared pointer? And that is true. Aha. That's interesting. So let's look up is constructible. Make sure that there's an order to this. So T args. If T is an object or reference type, and the variable definition T obj of declval of args is well formed, so if you can construct a T from args. So in my case, if I can construct a bool from this, then we're okay. All right, so this looks like it'll do the trick. So coming back here, if we replace this guy with this guy, and now we compile. Sorry, no, not quite. Like we said, the other way around. If bool, whoops, can be constructed from the invoked result type of this guy. I guess that makes sense. I didn't think about that. Is explicitly convertible to is the same as is constructible. Now let's see if this actually works. If our breakpoint remains on this line, that'll be interesting. It looks good. I think it's working because I see the breakpoint is indeed in there. Awesome. And then this one here should not compile because I don't have any code testing this code path. Interesting. So now let's see how this works. So we come in here. See, now we return traverse 2, which gets inside here. And so now because of the deduced return type, it's really complicated to read this this line in the call stack. But anyway, and it comes in here, and then it says if auto result callback. So it's going to do this. It's going to call the callback. So here we are constructing another one. Thought I was doing a const ref. I don't understand why. Const shared pointer node. So why is it constructing a shared pointer here? Probably because of the const. Huh. Fascinating. No, this should be okay. All right, anyway, this find I think works. Oh, so we didn't find. Oh no, that's it. The first one will fail, so we're going to return a failed result. I don't know why the debugger steps on the line when it's not actually going to execute it. Anyway, now this one should actually return what we're looking for. So first it's going to go in here again. Don't know why we're constructing that shared pointer. Then we do a find. Now we're going to return it. This returns that one. And then this guy sees the result, returns it. And we are technically done. And we've got our variable. Sweet. Very nice. Very nice. Cool. So technically these tests should pass. Let me just make sure that's still true. That behavior should not have changed. Yeah. Okay, and then one more thing. So this works. And I just want to try, if we go back to the version we had where we don't return, so just make sure that path still works as well. So we go like this. Actually, it's just like this. So this is the old version where we captured result, we store it, and then we just keep going. This should compile, and this should pick the alternate path. And it does not compile. Oh, because of this. And because of this. Almost. Right. Now this is what I was a bit concerned about, was void function returning a value. It doesn't like that. This, by the way, is the reason why there's someone trying to get a feature. Well, there are some people who are trying to get a feature in C++ called regular void. And the idea is to stop treating void like something special, because when we do, we always have to have these two code paths for those things that return void and things that return anything else. And this is an example of that. See, I cannot construct an empty void. So they want to add a type like void t, and that void is basically of that type. So constructing, this would actually be valid. Now, because it's not, I have to do this, this thing here of having two code paths. I mean, I may as well, for now there, I now have exactly two code paths. So one here and one here. Oh, actually this doesn't make sense anymore, because I need this to be on the outside of the if. See, this is why it sucks, the regular void thing. Because now what I need to do is I need to have this if actually be on the outside. Like this. And effectively repeat my code twice for the most part. And that probably did not work. No. Let me pay attention here to the parens. Ah, okay. This goes with that. This goes with that, and this goes with that. Okay, there we go. So this will be like void return types. Or in fact, it's not just void. I suppose it's, yeah, I suppose it is void. Anything else wouldn't work. Basically, there's only two cases that are supported. Something that can be implicitly converted to bool. Otherwise, it has to be a void return type, because we ignore the return type. So, yeah. Probably I should static assert that the type is void at this point. Anyway, I don't mind it that much because actually now the code's a bit more clear. You can see exactly what happens in the case of oh, actually this should be down here. Like that. So this is what happens if you have your callback return, say, a shared pointer, a raw pointer, a bool. It'll go through this code path here. Returns a bool or type convertible to bool. Shared. And in here, callback returns void. Okay, so let's see if this builds. It should. And now you'll see I have a breakpoint here. It should actually end up moving down here, or it'll be disabled. I think that's what happens. Yeah, it gets disabled. And if I put one here, this one gets enabled. So my code should still work, just because, yeah, it should work. And result, because I'm storing it with the capture and all that. Everything passes, but we're gonna stick with the other version, but both should work. So now at this point, we're gonna go back to this one, remove this version here, clean it all up. Yeah, I like it. All right, so now we find all the traverse 2s that we have. That's all of them. Call it traverse. This traverse here template will replace there was one more thing before I do this. I was curious, why were we constructing that shared pointer even though I'm passing by const ref everywhere? Let me take a look here. I think I should remove this const here. What's going to happen if I do this is, depending on the type you pass in, if it is already const, it'll take on that type here. But if it's non-const, we still want this code to work. I mean, you're allowed to pass in a non-const object here. Let me step in one more time. Maybe I'll see it in the call stack. Oh, something it doesn't like. Maybe I do need const. I guess it's because of the ref. I think for the callback, I'm going to remove the ref there. I technically should move it in. Okay, so here, we're calling operator for scope. We're going to get into here. See this? Why are we constructing a shared pointer here? My callback is accepting this type. That's very hard to see. Okay, here. Oh, look. It says shared pointer of scope and it wants to convert it to const scope. Huh. Why did it lose its type? So this is the type of my node pointer. So why do I have these inverted? That's kind of weird. Oh, I think I know why. It's because this type here is not a const scope. That's why. Huh. I see. Can I make this const scope? I mean, once it's stored in here, I guess we don't want it to ever change. Yeah, doesn't like that. Probably because I have many places where I don't do the const scope dance. Let's see. It would be nice if the compiler actually showed me where it's failing. It's just saying that there is some place where I'm doing this conversion from const to non-const, but it doesn't want to show me where. That's just extremely useful. All right. So the other way to fix this, of course, is to remove the constness on the scope here. So like everywhere I have const scope, which is only these two places, if I just do this and match basically the type that I'm passing in, there should be no more conversion, which is fine. I think I know why this happened. It's because I had the constness here. Okay. There we go. No more shared pointer construction here, which means that node's ref count should remain 1. So there you go. Uses is 1 here. Looks good. Test passes. All right. All right, I'm satisfied now. So let's do the thing. We'll move this and replace the one that I have higher up. What? Why don't you like this? Yeah, okay, because there's more than one instance. That makes sense. Debug symbols, we're going to replace these. Just going to do a build all. All right, cool. Let's put a little comment. Traverse takes a node pointer type on which that is expected to be a pointer like and have a member name. It performs an in-order traversal of the tree starting at node pointer, invoking callback of cur node, in each node. If callback returns a type convertible to bool, returns a bool or a type convertible to bool, it will stop as soon as a valid result, as a true type result is returned. And returns that result. All right, I think that's clear enough. Yeah, I don't know if I'm ever going to do this to do. Not sure if I even want that. All right. So that took a little longer than I thought, but it always takes longer than I think, to be honest. Oh yes, I don't want to check that in. Let's say make traverse improve the traverse function template so that it optionally or conditionally uses the return type of callback. It will stop recursing or stop traversing as soon as it returns a true, like returns this result. Okay. So the next thing I wanted to work on, I'm sort of running out of time here, but I can start this, is tests for indirect types. And for that, I actually went back in the history of when I was writing this stuff, and I have here a little test where I sort of started doing that kind of thing when I was testing it manually. So I think I'm going to base myself off of this here. So indirect types, we're going to grab, whoops, I'm going to grab some code here. It's going to be pretty similar. We're going to want this pretty much all the way up until here. And of course, we're going to change the program. So this declares a pointer. Now, of course, I'm changing values here. We're not going to actually see any of that. So I suppose I could remove all this. It would be great if I could do runtime checks here, but I can't. So this is all about just making sure that the parser does the right thing. So we start with an integer. I get a single pointer level. Maybe I'll call it P1. P2 just points to P. Then I have a reference. I called it R3. Maybe I'll call it R1, and this is R2. These are two references to the same thing. Yeah, that was more about runtime, making sure they pointed at the same thing. So that's less interesting, I would say. Maybe this should be a reference to R1. Can I check that they refer to the same? I guess I can't. Not at the type level. Well, maybe. Actually, yeah, I think I can. Yeah, I think so. And then over here we have a double direction pointer, so PP, triple pointer, and then a reference to a triple pointer. And that's it. I suppose I should also do indirect pointers to structures, different types, not just primitives. Because here I'm just doing pointers of type int as well. So I can do a few different types. I should also try const pointers. I don't even think I tried that. I don't think I've even tried yet a pointer to function, so that's not going to happen soon, but I'll put a to-do anyway. All right, so let's start with this. So what are we expecting? When we get this, we're going to want to get find a variable. We'll start with this. So A we know is going to be an integer, that's fine. But let's find P1 here. So this now, yeah, its name should be equal to P1, of course. And the type should be int star. Then we want to cast it to an indirect type and then do the tests for indirect types. So this one basically just has a name, which we already checked. But what we also have here is the type. So here is where we're going to want to see, is this type like an integer type? And in this case, it's going to be like, making sure that the type is of a primitive type. I don't know if I want to be able, yeah, I don't need to check everything here. As long as we know that it's an integer primitive type, that should be good enough. I don't even know if I should be testing if it really is a primitive type. Maybe I should just check the name. I don't know. All right, let's just start with this, see where this takes us. So stabs parser indirect type. Where is it again? It's the here? Yeah. G-test filter equals 2. This should only call, yeah, perfect, because I have that filter on here. So let's see, compile the code. Oh, expected equality of these values. So this is not compiled correctly. So why does it continue going? Oh, right. Yeah, that's not good. We should make this a little bit more strict, because if it fails to compile, we don't want to keep going. So this has to be an assert. In fact, that probably all of these have to be asserts. Now I think about it. Assert, was it? Assert true, assert equal. It's not assert equal? Why didn't it like that? Doesn't like this. No suitable constructor exists to convert from void to std file system path. Oh, I see. It's because we're inside a function and it returns an fs path, and assert. So that's how assert works. It returns when it fails, so it doesn't keep running tests. This comes back to that idea that functions that do assertions should return that assert impl type or whatever it was. I have two options. Either we get rid of the checks in here and have this thing, you know, just be a regular function, and then where we compile source, we just make sure that the RST file we got is valid. So if anything goes wrong, it goes wrong. And the truth is, the only place it's ever going to go wrong is on the first one. The rest here shouldn't fail. If we made a valid process, you know, none of this is going to fail. So the only one, maybe, yeah, even this, all of this should succeed. So I think I'm going to go for that. I'm just going to say, and then the only other concern I have is if we did create a process It's the usual RAI problem. Want to make sure to destroy and clean it all up. So I should technically stick this in a class. Okay, that's okay. We'll do that later. So if result not equal to 0, return like this. And we'll do the same thing below. Same thing with process return. Well, actually, process return is a bit different, isn't it? That's the one we care the most about. Okay, for now, I'll just say here, on the fence. Let me go check here. Where was that stuff about? Okay, let me just close all this. It was here, and it was something about assert result, assertion result. That's it. It's not quite that, is it? Assert just wants to return without any kind of result. So maybe alternatively, all I need to do here, okay, let me go back. Let me try something else. A little bit less involved. What if compile source really returned the path as output? What would that change? Let me just see again, what was the error? Yeah, that's it. It just wants to do a normal return void. On failure, gtest fatal failure, return gtest message. So that's where all the differences are. It's funny here, it actually says return gtest message though. Oh, okay. I guess what I don't get here is, say, even if I put the assert, it'll just return, but then it'll keep running in the calling function. So really what I would have wanted here is something even more fatal. Something that would throw, I suppose. You know what I mean? Not just a return. Suppose I don't really know what the right way to do this is. Yeah, I'm coming back to the idea of just, yeah, I think I'm just going to go for that because I'm not quite sure what the right path is. Guess I'll learn more as I keep using this thing. Okay, let's see if this actually does it. Now, this thing will fail to compile. And now it'll fail the test like this. My suspicion is it's this line here. No, okay. All right. So what we'll do now is we'll actually try to compile this. I must have some silly mistake here. But let's write an actual piece of code here. Whoops. Oh, there it is. So P here is unidentified. I meant to put P1. P1, okay. P1 here and P1 there. Let's see, does this build? Something it doesn't like. Oh, int main previously defined here, line 2A. So yeah, I gotta comment out this code here. All right. Actually curious. I don't remember if I handled the const type here. Let's see if this works. Is CPU on there? Oh, sure is. Okay. Ah, but you see, I call it an int star. Probably because the compiler, the debug info doesn't care about const, if I recall, which is really unfortunate. So here it is. CP1 defines type 31, which is a pointer of type 7. So that's basically a pointer to type int because T7 is int. There it is. So yeah, that's it. I remember now. So we're going to actually encode that in our test, that consts don't appear. And then maybe one day, if they ever do, we'll deal with it, and the test will fail. All right, so let's get back to running this test. So now the compilation should pass. Very nice. All this should be good. Here's the parse. Looking good. We should find P1. We did. Its name is indeed P1, and its type should be int star. Now we're going to cast the type to an indirect type, which succeeded. And we're going to get the pointee type by assuming it's primitive, which it is. And we're going to make sure that it's valid and that its name is int. And there you go. So that's good. Now the reason why I was on the fence about this cast here is because to write something generic like I did here, I don't want to have to encode type. So like, for example, right now these are all primitives, but I'm going to also try to do pointers to classes or structs, maybe eventually to functions. And so suddenly the type is not really an indirect, sorry, it won't always be a primitive type. Let me just try another thing here. Okay, I wanted to see if all of these would work. Then again, I guess, yeah. what was I was gonna say, the question is it enough to just check the name of the type, or do we want to go as far as making sure that the type here points to something valid? See, because all we have at the base level is a name. That's it. So one way to do this, and maybe this is the time that we do this, is like right now I'm doing like these dynamic casts, as you can see. Here's dynamic pointer cast on shared pointers. And I have been thinking that, you know, that instead of doing that, I can make my own little type system here. You know, so have like an enum with all the different types. It is a closed set of types, right? And do my own kind of RTTI, where the base type here could return what type it is. Each derived type would return the enum. If I did that, all of a sudden, I've got a runtime enumerator that I can use. I can even make my own casts, like an as function, where you give it an enum and it'll return that. Well, yeah, that's less interesting, I suppose. But yeah, basically if I encode the types as enumerators, then I can do more simple testing, I suppose. Otherwise, like I said, I'd have to go back to having like a function. I wouldn't be able to store in test parameters, you know, a type in here, unless it's templated, which I suppose it could be, but then I can't have an array. There's all these problems that come with using the type system, at least for testing purposes. Something to think about. So sort of what I'm saying is I'm imagining like type here. I would actually probably put it directly inside type. So something like enum class. Although I have to give it a name, don't I, if I do that? Do I? Maybe not. And then we go and say, you know, unresolved type, primitive type. I think it does want me to give it a name. A scoped enumeration type must have a name. Yeah, let's just do this. So primitive type, like all the types I have here. In fact, I guess I would just say unresolved primitive enum an array struct and indirect. Whoops. See, it's funny. If I remove this last comma, it does this, the Clang format. If I leave the comma at the end, then it leaves it like this. So strange. And then the idea would be to have a virtual function that returns this. I suppose I should give it a name. This is kind of annoying because normally this would be called type, but I can't have it be called type, right? I don't know, eType. Okay, and then the idea would be to have a pure virtual eType function Type, get type. Yeah, something like that. Or what? What would this look like? So alternatively, this would have to be like some kind of function, and I wouldn't be able to write a loop like I did here. I wouldn't be able to put it inside a table. It's a bit annoying. See here, if I use auto, I would be able to say pointee type here. Could I do that? No, this would have to be a template function template. Yeah. See, am I allowed to do this? No, can't do templates on on local functions, I suppose. Yeah, you can see here the mess of having to deal with templates. I'd have to like basically make a template function outside. And that's really not what I want to do here. All right, you know what? I'm going to stop here. I'm going to think a little bit about this and decide what I want to do. And next time I continue on this, I'll have a decision as to whether I want to go with some kind of RTTI system like this or try to keep these as types and figure out how to test this. So guys, I'm going to stop here. So thanks for watching, and I should be back next week on Tuesday, same time, around 9 p.m. Eastern. So yeah, thanks for watching.